Hi class, this is number 1 on 8.3. So it says if n equals 260 and p hat equals 0.45, construct a 95% confidence interval about the population proportion. Round your answers to 3 decimal places. The first question, and these are some preliminary questions that I feel like in the real world, you have to really ask these and really check these, but for homework and for this class, like we just kind of assume that we kind of ignore them and we just kind of say, hey, those are met, because if we don't meet those, then we can't do this problem and it's kind of a useless problem. So, I mean, they could throw you a problem where these aren't met. So we do want to, answer these questions, but especially this first one, it's almost, they say we always just like kind of wave it and be like, is it safe to assume that n, that's the sample size, is less than 5% of all subjects in the population? So they don't even really tell us information about what population they're interested in, but and unless it's a pretty small population, this is almost always within being 260, it's almost always met. So here's the actual equation. It says that the sample size has to be less than or equal to 5% of the large N, the large N being all the people in our population of interest. Now, if the population of interest is like all of Americans, which that might be it's a common population that's 330 million. And so 5% of that is going to be a pretty large number, and it's definitely going to be, bigger than n, but let's just calculate it. Let me even if we were interested in maybe just high school students in the United States, I mean, 260 is such a small kind of number that for most populations, the answer is going to be yes. That it's a pretty small sample size. Let's see, especially when we're talking about populations like the whole United States, or maybe even all the kids, in a school, or it's a pretty small number. Okay, let's calculate this. So I'm just going to do 33 million. So times by 0.05. And I just made up 330. Actually, I calculated what the US population actually is right now. It's close to 33 million. So I'm supposed to be multiplying that by 0.5. So times by 0.5 equals, and I don't know why it doesn't want to, okay, maybe it's not, I don't think it likes the parentheses. Okay. So let's see. Oh yeah, now it was giving me an answer 0.5. Okay, so like I'm seeing here, this is 16 million. Right? Yeah, this is 16 million. So definitely 16 million is going to be larger than 260. So that if this, they don't tell us really, but if our population, like it has been for many of these problems, is the whole United States of interest, then our sample size is definitely smaller than 5% of the entire population. And it's kind of a silly question for them to ask us, because they really should give us the actual number in their population, which they don't in this problem. But if they don't give you enough information for that problem, then you could just say, I would just say it's safe to say, just say yes for this first part. And then, I mean, unless they give you the large N, and if they give you the large N, then you could actually calculate it and double check it. But if they don't give you a large N, we just kind of waive it and be like, yeah, that requirement's met. So we say yes. Verify that this is true, that N times P hat times 1 minus P hat is greater than or equal to 10. So like it is another requirement that sometimes just gets forgotten. And when we're like students and we're in the real world, we would have to make sure this is true, but this is kind of like prerequisite things that if these aren't met, then we couldn't even do a problem. So like these are usually just, we just wave our hand and say, hey, those are met, let's do our problem now. But let's go ahead and verify it as if we were, in real life doing this problem. So we would plug in the N for 260 and plug in the 0.45 for our P hat, that's the proportion, sample proportion, and then 1 minus 0.45. And we have to verify that that number is in fact greater than or equal to 10. So we just calculate that, we put that into our calculator. I'm gonna do the 1 minus 0.45 first, you could, or you have to make sure to put that in parentheses so that it does the order of operations correctly. So let me just do 260 times by 0.45 times by, and I'm going to put it in parentheses, 1 minus 0.45 in parentheses, and then now it's 64, which is larger than, so 64.35 is in fact larger than 10. So we can say, yes, that requirement has been met. So we just have to make sure that and so that 60, okay, they actually ask you for it, 64.4. All right, and then the next thing in this problem is they want to actually find the confidence interval, and that's the biggest, most important information. And they want us to say, hey, can you give us with 95% confidence that the true population proportion is between these two values? So all we have to do to find that is to write down all the information that we're given in the problem. So let me roll, and I'm not going to do any formulas. I'm just going to find this on the calculator. So we write down the N equals 260. We write down the P hat is equal to 0.45. And we write down the confidence level, CL, is equal to 0.95. So I have that all ready for me when I need to put this information into the calculator to find this confidence interval. So I just go to my class calc now. And I'll go through, I just go to stats and I go to tests. And then I'm going to go, instead of, when we did with the mean, when we were finding a confidence interval about a mean, we did T interval. So now that we're talking about proportion, we're going to do one prop Z interval. One prop Z interval, which is right next to it. And then it tells us what we actually need to input here. And it's a little bit different than the information that we have, so we have to kind of pay attention here. So it's telling us you need to enter the number of positive outcomes. So they said 45% of the 260 people had the outcome that we were looking for. So we need to actually find out, well, what is 45% of 260? Because that's the number that they want us to put in here. So just so you know, like when you calculate the P hat, it's equal to the X, that's the number of people in the sample with your desired trait over the total N. See, we're given this and we're given this, but we're not given this. But it's easy to find this answer. And that's the number that they want us to input over here. It's really easy because it's just 45. It's just, they said the sample proportion is 45% of them have our desired trait. Well, what's 45% of the sample? That's going to tell us what the X value is. So our X is equal to whatever the P hat is times by the N. So it's going to be 0.45 times by 260. And sometimes, sometimes problems are going to give you just the X value and you don't have to do this extra step. And some problems are going to give you the sample proportion, the 0.45, and then you are going to have to do this step. So it just depends on every problem. but I already did this cancel. I believe we get 117 when we do this. So that's the first number that I input here is the 117. And then it asked me to enter the sample size. So then I put in the 260. And then now it asks for the confidence level. So I put 0.95. And then now here's my confidence interval. Here's my lower bound, the 0.38. And like I said, if you're using a TI-84 calculator, it usually just like puts the lower bound in parentheses. And I think if we round to 2 decimal places, what, 9.39 to 2 decimal places, and then this one's 0.51. And there is my confidence interval. This would be your lower bound and your upper bound. So let's just double check our answer over here. So see the P, and literally what I like about class calculator is you literally looks exactly like the answer. Whoa, what did I do? The answer here literally looks exactly like how you need to input it on your homework. So sometimes they vary a little bit, but they're just trying to say, so yeah, the 0.39 is exactly what we wanted to enter, and the 0.51, and there we go. Oh, they actually said to 2 to 3 decimal places. So actually, let me just back up here. If we rounded it to 3 decimal places, I think we just got lucky that I rounded to decimal places in an accident. You know what? Sometimes they actually want 2 decimal places, but they tell you 3 decimal places. But okay, so if I did 3 decimal places, I would be looking at the 5, and I'd say I'd add 1 to the 9. If I add 1 to the 9, that would give me 10, which I would have to add 1 to the current one, so it would end up with 0.39. And then here to the 3 decimal places, this one would be less than 5, so I would not add 1 to the 0, so it would be 0.51. So even though they're saying 3 decimal places, the third decimal place ends up being a 0 in both these cases. That's why you have 0.39 and 0.51. All right. I hope that you found this really valuable. Let me just write this one more time for those of you that have trouble with like this rounding portion of it. Let me just write this for you. So we wanted 3 decimal places of accuracy. And so here's the 3rd decimal place. And so I had to look to the number to the direct right of that and ask, is it greater than 5? And 5 or greater. Is it 5 or greater? Yes, it is, which means I would have to add 1 to this place value. If I add 1, that makes 10. And then I would have to carry it, and I would have to put it over here, and that would make 9. And then next one would just come down. So this would be rounded to 0.390. So I hope that makes a little bit better sense to you. All right, well, email me if you guys have any questions. And I think it's real similar on the TI-84. You just do 1 prop Z interval. I don't know if you need to put the X value in or you need to put the P hat in. I'm not sure. But anyways, have a great day. Take care. Bye-bye.